geometry, people. Wait, you aren't in geometry, you're AP Pre-Calc. It's been a long day. All right, guys, today we're going to be looking at 3.11 and making a bunch of errors on screen. Close. All right, we'll see if this goes better than my earlier attempt to make a video on this computer. All right, so we're going to look at secant, cosecant, and cotangent some more. Okay, we're going to look at them as the reciprocal identities. If you want to try this, go for it. Try to evaluate these with the unit circle. If you don't, that's fine too. Just follow along. So first thing that's good to review is to find secant of 13 pi over 3. I have to remind myself that 13 pi over 3 is on the unit circle. So what I'm going to do is I'm going to keep subtracting, this lags a little bit, subtracting 2 pi from that until I get it to be on the unit circle, right? Remember, 2 pi is actually 6 pi over 3. What's that give me? 7 pi over 3. Still not on the unit circle. So I subtract another 6 pi over 3. And I get pi over 3, which is on the unit circle, right? Over here. That was poorly drawn. So pi over 3, when I'm looking at secant, remember that's cosine. So not just cosine, but it's going to be 1 over cosine, or 1 over my x. Well, my x value there is 1/2. So I'm going to do 1 over 1/2 because it's secant. And because I'm dividing by a fraction, I multiply by the reciprocal, as I was helping my daughter do her homework today was also doing. All right, let's do another one. So we're doing cosecant of 17 pi over 4. Again, that's not in the unit circle. So I'm going to keep subtracting 2 pi from that until it is on the unit circle. Or actually, I'm going to subtract 8 pi over 4. Find that common denominator. Man, that's blinking. Oop, that's a 4. And actually, I'm going to do that twice until I get to pi over 4. First time didn't get me there. Second time did. Okay? So at pi over 4, now remember cosecant's 1 over y, we're going to call it. Also known as 1 over sine, which you'll see later. So my y value is root 2 over 2. So I'm going to do 1 over root 2 over 2. Get out of here. All right. And now again, I multiply by reciprocal. And I flip it around, and I get 2 over root 2. And now if you rationalize that denominator, you just get square root 2. Okay? Times top and bottom by root 2. There we go. I had to get rid of that. All right, let's do cotangent. Seems zoom in a little bit. Make my life a little bit easier. All right. Oh, she lagging again. All right, so cotan 9 pi over 2 again. Now remember, cotangent is reciprocal slope, so it's x over y. Now 9 pi over 2 is not in the unit circle, so I'm going to subtract 2 pi from that until I get to my coterminal angle, which for this one it was pi over 2. All right, so that's pi over 2, and at pi over 2 I have the point 0, 1. Now my x coordinate is 0, my y is 1, so cotangent of it is 0 over 1. Oh man, this is lagging. Which equals 0. All right. Now remember with tangent, that was an asymptote because we had a 0 on the bottom. All right, D, secant. So when we're looking at secant for our unit circle, that's going to be 1 over, so that's going to be cosine, so it's going to be 1 over x. Now I'm just going to keep adding 2 pi to this until I get out of it. So I add 2 pi and add 2 pi until I get to, I believe it's going to be negative 5 pi over 6, 12, wait, hold on, I can do this, 12, 18. I actually get all the way, 7 pi over 6, because I add 12, gives me the negative 5 pi, add 12 more, positive 7 pi over 6. Now, what's my x value at 7 pi over 6? Well, that one's negative root 3 over 2. So I'm going to do 1 over negative root 3 over 2. I'm going to reciprocate it and flip it. So it becomes 2, negative 2 over square root of 3. Which, if you rationalize it, you get negative, oh man, this is lagging. Negative 2 root 3 over 3. All right. All right, I'm going to cheat for this next bit if you guys don't mind. So that way it's not lagging so bad. Now, it's nice dealing with those x's and y's, but what I really want you to know and put in your memories are these identities. Whenever you see cosecant, that's the same thing as 1 over sine. Whenever you see secant, that's 1 over cosine, and cotangent is 1 over tan. Now, also remember, tangent is sine over cosine. That's something we're going to start using a lot here soon. So cotangent, the cosine is on top. All right? All right? Okay. All right, okay. Anything too scary here? These are just going to be things that we're going to use all the time. All right. I wish I had a curtain. All right, how are we going to find the exact value of these? We're going to do the exact same thing we did before. Just remember they're flipped. So if I know what sine is, I know what cosecant is, right? It's just a reciprocal of it. And if I know what cosine is, I know what secant is. They're just reciprocals. All right, number 6, there's a lot to deal with. I wish I could cover up pieces. I'll do, yeah. This will be fine. We'll do it this way. Now, a few things to keep in mind. All right, they gave us that point, right? So I graphed the point. From there, what I would have to do is use Pythagorean theorem to find that hypotenuse, because to find all my trig ratios, I need my hypotenuse, right? So Katona, as a person once told me. So once I use Pythagorean theorem and find that missing hypotenuse, I'm good to go, right? Because it's going to be easy now. I can find sine. Sine is just opposite or hypotenuse. So 5 is my opposite, over square root of 29. Well, sine's 5 over square root of 29. Then cosecant is square root of 29 over 5. You just flip it. Okay? Same is true with cosine. Cosine would be my adjacent over hypotenuse. So secant is hypotenuse over adjacent. So negative 20, square root of 29 over 2. And then tangent and cotangent are done the same way. Okay? All right. I know I'm cheating here. All right, one more. So now, oopsie snoodles. All right. Actually, I wouldn't even draw the picture on this one. You don't need it. I'll show you how I would have done this. All right. So they did it. They took your sine and cosine, and they drew in a triangle, and they labeled the sides, right? They gave a 2. Actually, this is how I do it. So sine of theta is opposite or hypotenuse. So they did 2 square root of 30. Now, could you have done, let's say you didn't see this as well. Could you have labeled this triangle as 2 root 13, and this side as 13, and gotten the same exact answer, you could have. You would have. They would have canceled. You would have been absolutely fine to do it that way. All right. I'll show you guys how I would have done this one. I would have done this one without even drawing a triangle. Okay. So what I would have done is I would have done tangent is equal to sine over cosine, right? Yard. So I would have done 2 root 13 over 13, that's my sine, over my cosine, which is 3 root 13 over 13. All right. Very nice of this. All right, so that's how I would have set it up, and then I would have multiplied by my reciprocals. Let's try it spaced out. So I would times this by 13 over 3 root 13. Right? And my root 13s cancel. My 13s cancel. And I still get 2/3, right? And I did that by using the fact that sine over cosine is tangent. And then once I know that, I know cotangent because I can just flip it around. Okay? And then these ones you just flip. You just flip your function and then rationalize them. You know what I mean? It would have been 13 over 3 root 13. Then you have to rationalize your denominator. Okay? I hope you learned something, and I hope you have a good day.